Okay, so now we're going to find this very specific limit, and this is what's going to set us up for our very last section and our last set of topics. Okay, so we're going to take our function and we're going to plug x plus h in for x, and then we're also going to repeat this using just the regular f of x. Okay. Again, I like to do this all at once. I don't tend to do it in steps, but there are some who choose to do it in steps. Whatever works best for you is fine by me. So limit h approaches 0. F of x plus h is x plus h squared. That's right here. I'm replacing x, right? Plus 2 times x plus h. I'm doing it again right here. Minus 4. No x there, so I don't replace. Minus, and here's where I'm going to put f of x just on its own, no h's. So x squared plus 2x minus 4. All of that is divided by h. So here's where you just have to be careful with your algebra. You have the limit as h approaches 0. X plus h quantity squared is going to be x squared 2xh plus h squared. Distribute, and this is another place where I see a common mistake. A lot of times we only distribute to the x, and we forget that there's a 2 in front of the h as well. Minus 4. I'm going to distribute my negative as I go here. Again, another common mistake is to distribute wrong. X squared minus 2x plus 4. All divided by h. So now I'm looking to cancel. I have a positive and a negative x squared, a positive and a negative 2x, a negative and a positive 4, and we're left with the limit as h approaches 0 of, I've got a 2xh, h squared, and 2h, all divided by h. And very, very often, you're going to see that we have this common factor of h. Okay, so I'm going to factor out a single h of every single term. It does need to be present in every single term. So you've got the limit as h approaches 0 of, you've got an h here, left over will be 2x plus h plus 2 divided by another h. And here's where we're going to cancel those 2 h's out. Okay, so really your final statement, this is the end of the algebra portion, h approaches 0 of 2x plus h plus 2. And this is where we apply the limit. So again, above this was all algebra. From here on is limit, pre-calculus / calculus stuff. So here we say, I'm going to use direct substitution because this is a polynomial and I'm allowed to do that, right? Notice though, when I say direct substitution, I'm only substituting for h. In this particular example, I have 2 variables. I have an x and I also have an h. Only this h is substituted for 0. And actually, sometimes the way that this gets written is we draw an arrow through it going to 0 like this. All I'm left with, I would write 2x. You don't have to write plus 0 every time, but I just want to see that substitution, 2x plus 2. So this limit is equal to 2x plus 2. I'm going to say limit h approaches 0, f of x plus h minus f of x over h is 2x plus 2. And I think last time I put where f of x is equal to x squared plus 2x minus 4. We'll throw that on the bottom. Okay? I'll see you in the next example.